The next property of logs says that if you have a number of the form, if you have a logarithm of the form, let's say this time I take the base b of a to the power m, right? Then this actually is going to be equal to, you can take the m outside, equivalent to m times log of a to the same base b, right? So actually this can be derived from exactly this property, right? Now what we can do here is that we can write the left hand side. Now I'm going to quickly derive this for you. The left hand side is equal to the log base b of a into a into a, and I'll continue to multiply this m times. Right, now I know that the log of product of two numbers is equal to the sum of their respective logs, right? So I'm going to get this equal to log base b of a for this one plus log base b of a for this one, and I will continue to add these again. I will get m of these, right? And because I get m of these and they're all the same, I'm going to end up with m times log base b of a, right? So basically what happens is that the power of this number, right, you can bring it out. So let's take an example. If let's say you have a number which looks like this, log base let's say 3 of 25, right? We can write this as log base 3 of 5 squared, right? So we can bring out this power 2 outside. So this is going to be equal to 2 times log base 3 of 5, right? So this is what, this is how I can write, I can write a log when this number has a power, right? Now, if let's say I have a number of the form log base b of 1 by a, right, then actually this is equal to log base b of a to the power minus 1, right? And just like I did here, I can bring the power out, right? I can bring the m out. Now m in this case is minus 1, so we get this equivalent to negative log base b of a, right? So the power 1 by a is negative of the power of the log of a, right? Next, the next property, it looks like this. The log base b of a is equal to 1 upon log base a of b, right? So when I interchange the base and the number of the number whose log I'm taking, right, these two are reciprocals of each other. Now let's take the left hand side equal to x, right? Now if I convert this into the standard form, the power form, if I remove the log, then this gives me b to the power x is equal to a, right? I can rewrite this as b equals the 1 by xth power of a, right? Now if I take log base a of both sides, I get log base a of b equals log base a of a to the power 1 by x, right? Now I know that if I take the log base a of a to some power, I will just straight away get the power itself. So this becomes equal to 1 by x, right? Therefore, if x is log base b of a, then 1 by x is log base a of b, right? Hence, I have proved that when I exchange the base and the number whose base I am taking, it just becomes reciprocal. Next, for the next one, let's say we have log base b of a, right? We can write this as log of a divided by log of b to another base c, right? Now this becomes an interesting property. Why? Because now I can introduce a completely new base, right? And I can express this log in this form, right? Now how do I prove this? Let's take the left hand side equal to x, right? Now because this is equal to x, I can say that b to the power x equals a, right? Now let's take log c on both sides. Let's take the log of c of left hand side and log of c of right hand side. So we get log base c b to the power x equals log base c of a, right? Now I can bring this x out. I get x log c of b, log base c of b equals log base c of a, and x, which was nothing but this thing, log base b of a. From here I get x is equal to log base c of a divided by log base c of b, right? So simply put, if let's say I have a situation like this, log base 2 of 5, right, then I can rewrite this as log base 10 of 5 divided by log base 10 of 2, right? Then the next property is log, uh, let's say this time the base has a power, base to the power m of a, right? This is equivalent to 1 by m